Let's do lead code 3234. Count the number of substrings with dominant ones. This is a pretty tricky problem just because of the constraints. Here the length is 10 to the power 4, and if we try to do a big of n square solution, then it won't pass on lead code. So we need to do some improvisation on our n square solution. If it would have passed in of n square like easily, then I think it would be an easy problem, but since it won't, and so that's why it is rated medium. So we are given a binary string and we need to return the substrings from S with dominant ones. So, and it is defined what it means for a string to have dominant ones. So that means the number of ones in the string is greater than or equal to square of number of zeros in the string. So let's take this example and try to understand what it means to be a dominant string. And so I am given this string, right? Let's take this string. So I have a single one. So number of zeros in this single one is 0, and number of ones in this is 1, right? And if I calculate this value, the number of ones is greater than square of number of zeros. So number of ones is 1. It is greater than or equal to number of zeros square. So 1 greater than or equals to 0. So basically this is a dominant ones string. That's how it is. Like this string is defined in the problem, that if a string has this condition satisfied, then it's the substring is a dominant ones, right? Similarly, if I like only have 1 1 1 1, then this will be a valid string according to our problem. Now let's take this example wherein I have 0 0 and 1. Again, if I have a look, number of zeros are 2, number of ones is 1. Now if I calculate again, so 0 square, no, basically number of ones is greater than or equal to, that is the condition we will be checking for, and this will be 4. 1 greater than or equal to 4, this is false, so this is not a valid string, right? So like if we try to do it in a brute force way, then we can, for every index I, we can go to all the index j, we can keep a track of basically what is the number of zeros in that substring, and we can calculate the number of ones. We check for this condition and we say this is a valid string or not, right? And then at the end we can return all. But that will be a big of n square solution. That too, if we can calculate this number of zeros and ones in the single basically open time, but we can, with that the very standard thing, we can do that. But still this n square solution is not good enough, right? We need to do some improvisation on top of this. But what we can do is, we know that, so basically the condition we are checking is, so this is ones and this is zeros. So we are checking these, basically we are, for every every string, we are doing comparison based on these values, that string will be a valid string or not a valid string, right? So there can be only 3 scenarios here, right? This can be either greater, or this can be greater, or they can both be equal. And so for if let's say I can escape my some number of j, so I will still do the same thing, wherein I will fix my starting node, I will fix it. So my I will be this pointer here. What my j will do is, instead of going it like one by one, I can sort of skip some steps based on these values, because since we can see that this is z square and this is a single value, right? It's a linear value and this is an exponent, right? A square value. So basically this value will move faster, so we can sort of jump ahead some positions based on how much like difference there is between some these values. So let's take some example. Let's say I have this 1 1 1 1 1 1 1, and then I encounter 0. I have a I here, I have a j here. Now here I can have whatever value 0 1 0 0, right? Now let's see these, how many are these? So these are 9 ones, and this is a so basically if I say how many zeros are there in my current substring is 1, and how many ones I have 9 ones. Now so first let's check that condition we have. So 9 is greater than or equals to 1 square, right? And so yeah, this is right, this is greater than, so this is a valid string. I can include it in my solution. Now instead of jumping just one step, I can jump a few steps because based on these two values. So let's say I try, if I include 1 here, then this will still be a valid string. But let's say I encounter all the zeros after this. So what is the maximum number of zeros that I can include in my, basically in this string only? Till that point, this this string will still be a valid string with dominant ones. How I can calculate that is, let's say I add some k pointers, k values after this, and so in that case, how my condition should satisfy that is, I would have added k ones, right? So here, let's say this, now k should be less than, so I need to find the first value where k is less than 1 plus k square, right? So this is the sort of a condition. So we need to derive it, and we need to come at the exact solution. But I am going with the basically the thought process about why we are doing this. Because I know if I increment by j pointer by 1, and it doesn't matter what value I have, that string will be still be a valid string with dominant ones, because I know that my number of ones is 9 and my current 0 is this. So let's try to solve it for, so basically this will be z square and this will be 1, right? So let's say z is equals to square root of 0, right? Now I increment my number of k, so let's say k plus, so I add k this side, right? And let's say these many indices I am skipping ahead, so basically this will be root of k minus number of 0. So I can jump a maximum of, so till I need this k value to be greater than or equal to 0, right? That then it means that I will be able to skip. So let's calculate for this example only. Herein I see, so our number of ones are 9, right? So let's do square root of 9 will be 3 minus my number of zeros, that is 1. So this will come out to be 2. What this means is, from this pointer I can go to 2 pointers ahead, so I can go till here, and it doesn't matter if I encounter a 0 or a 1, my string will still be a valid string, valid substring, right, with dominant ones. Because let's say I increment my j here, now my j comes here, so my ones are still 9, my zeros are what? Zeros are 2. So if I check the condition again, 9 greater than or equals to 2 square, which is 4. So yeah, this is still a valid string with dominant one that is defined in the problem. Now again I jump by 1, so now my zeros are 3. Again I check for that condition, 9 greater than or equals to 9, 3 square. So this is also a valid string according to my problem, right? So we don't need to increase our j to here or here. I will just increment my j directly to here, and I can, in my solution, I can add these many strings, right? So so basically, if you see, we are skipping ahead. So in the second loop, basically for J loop, we are not going through each and every position. In worst case, we may be going, but it will cancel out a lot of cases where we don't need to basically take in consideration these values, because we already know, yeah, this doesn't matter if there is a 1 or 0 here, that string will still be valid because of our particular, basically previously what exactly we have, already we have, right? So basically this is the one scenario. Here my number of ones was greater than 0 square, and this is what I needed. This is the valid. So I encountered incremented my solution and moved J, right? Now the second scenario is my zeros are exactly equal to my ones are exactly equal to 0 square. So let's take this example. So let's say, so this is 4 and 0 0, so 2 square 4. So yeah, so let's say my I is here, my J is here. In this case, what is the number of ones I have? I have 4, right? And my zeros are 2. So 4 is equals to 2 square, that is 4. So this is a valid string. Now in this scenario, what I will do is, if I move any of the pointer wherein I move my J, so that I'm not sure that string will still be a valid substring or not. So I will just basically, in my result, I will just include this, and what I will do, I will just increment my J. So we can't do anything much here. So this is a sort of a second scenario. We may have combined it. So I think if so here the K value will be 0 sort of thing, right? So we won't be, if we can basically combine these two cases here as well, right? So in that case, for equality, the K will come out to be 0. So I will still be getting only one solution. So basically this is the one solution I will be getting, and I need to jump by 1, right? So this is the second scenario. Second is pretty similar to the first, whatever we had. And the third is 0 square is greater than 1. So these strings are not valid ones, right? We need ones to be greater than square of zeros. So these strings are not valid one. Now for this, what we can do is, let's say I have 0 0 0 and 0, then let's say I encounter 1, or rather let's have a 3 zeros only, right? Now my I is here, my J is here. This is 1, number of zeros is 3. Now let's see, how many should I so we know this is not a valid string that is being asked in the solution, but 0 square is 9 and my ones is 1. So if you see, there is a lot of difference, and in order to make this string a valid string, I need at least 8 more ones after this index, right? And then only it's possible, and that is that this is a maybe case. Like if I encounter a 0 in between, then again that range will increase for me. So there is no point of checking here J in this range, because I know that my 0 square is 9, so I will need at least 9 ones, but currently I only have a single one. So right, so what I can do is I can just increment my J from here all the way to here, and then again I will check if the solution exists, basically if that is a valid string, and when that will be the case, because in the in this range I don't have any zeros, so that means this would be a valid string, so we can increment it and then again we move ahead. So we can basically skip all these J's. We don't need to check these J's because we know that these won't be a valid string even if we are encountering continuous ones, right? So basically these will be some optimization we will be making. And so yeah and yeah, just we for the like out of bound so we can we the length of our sub like string is finite, right? So in this case, say in this scenario, if our j moves out of n, so there is no issue. In this also there is no issue, but yeah, in this we are incrementing, so we are including them in our solution. But let's say I have this string till here only, so basically we also need to keep that thing in mind, that we are not going out of bounds, right? Yeah, so let's try to code this. Okay, so I have written this. We are getting the length here of our substring. Now, one thing we missed here, in order to compute this number of zeros and number of ones, we will just need this prefix concept we will use, wherein we will populate this with initially. So if my current index is 0, I will start it with 1. So basically, this is a pre-computed array of representing the number of zeros, right? Number of ones we can calculate by length, doing length minus number of zeros. So that we will see later on. But so this is like a simple straightforward thing wherein we are doing if we encounter a 1, we will increment a value from the previous value whatever we had, otherwise we will just add 0, right? So this is my prefix array of number of zeros. Now we are just doing the, so I will start. So this is our outer loop wherein we will go through each index. So basically what that signifies is we will be starting from this position. So also right, so basically if we just take this substring, then there are lot of substrings that those are valid, right? But we are interested in the strings substring which are just starting from this node. So this will simplify our calculation process. So we will start j from that I only, and we are counting the number of zeros and ones. So number of zeros we can count, right, till number of zeros till j index, and we can decrease the number of zeros till I minus 1 index if it's possible. Like otherwise the basically if it starts from 0, so whatever is at j is the number of zeros from in our substring 0 to j, right? And number of ones we can calculate. So this will be length of my substring, the current substring which we are considering, and I can decrement the number of zero, right? And so here we had only two scenarios, right? So I have sort of I have combined these two scenarios basically. The 0 equal to 0 and greater than, this is equivalent basically if I have my k value as 0 in this condition, in this situation, then it will be equivalent to this second condition, right? So I have combined them. So first let's have a look at if whatever z square is greater than 0. So this is basically the second scenario wherein we need to skip these values, right? So here we saw, right, my z square is 9 and I only have 1. So I know I need to skip 8 points. Before that I won't be able to find any valid substring, right? So I just made we just made this jump here. So we will skip these many j's. Else I'm calculating basically this this is I'm casting here, then I'm calculating the square root of o, and right, so we are basically just the k value which we were calculating here. What's the maximum that we can go? So here, right, what the maximum we can go till that point we will have a valid substring, right? So and this is the index out of bound condition. If this goes out of bound, then I need to consider this, and so basically these will be my number of substrings, right? I need to include j as well. Otherwise, I will just increment k plus 1. So basically, so k are, if you have a look, like k, what we did was we were here. So basically, this is already a valid substring. The k value which we calculated 2. So basically, these two we are considering. So total number of substrings that are like valid are k plus 1, right? So this is what we have added here, and I will increment basically the j pointer by these many positions, right? So let's try to run and submit it. And it works.